Hi, John. Let's take a look at your question here, one answer at a time. The important thing here is that we're looking at a graph of the derivative, not actually of f of x. So choice one, f has an inflection point in the interval between -1 and 1. Inflection points occur when your second derivative, i.e. the derivative of your first derivative, the derivative of this red function. Inflection points occur when that derivative is equal to 0. So if we were to try and sketch the derivative of this red function, again, the derivative is the slope of a tangent line. So the second derivative is going to equal 0 when you have a horizontal tangent on this function. All right. So the second derivative is going to equal 0 at -1.5 and +1.5. So those are the only two places where the original function could have an inflection point. And since neither of those is between -1 and +1, that rules out that possibility. So now our second answer, f is increasing on the interval from -3 to 1. Well, I went ahead and put a number line down here with each of our critical points on it. Again, critical points are where your derivative is equal to 0. So we've got a critical point at -3, we've got a critical point at +1, we've got a critical point at +2. And then how do we define increasing and decreasing? Well, a function is increasing whenever its derivative is greater than or equal to 0. So everywhere here between -3 and +1, the derivative is positive. It's above the x-axis. So if your derivative is positive, then your function's increasing. Where the derivative is negative, over here to the left of -3 and in between 1 and 2, your function is decreasing. So this function is decreasing until we get to -3. It's increasing until we get to 1, decreasing again until we get to +2, and then it's increasing again. So f of x is shaped roughly like this. And it is increasing everywhere from -3 to 1, again, because everywhere between -3 and 1, the derivative is 0 or bigger. So that's a true statement. And then our last one here, f has a relative maximum at -1.5. Well, no, the derivative has a relative maximum at -1.5. But the original function, relative maximums and relative minimums, can only occur at critical points. Critical points being, again, these three places where the derivative is equal to 0. So the only possible place to have relative maximums and minimums is at -3, at 1, and at 2. And in this particular case, we're switching from decrease to increase at -3 and at 2. So those are relative minimums, here and here. And then at 1, we're switching from increasing to decreasing. So we've got a relative maximum here, but that's not at -1.5. So the only true statement here is the second one, that f is increasing on the interval from -3 to 1. Hopefully that helps make a little sense out of that problem.